Earlier in this module, we talked about TCP and UDP. Those were layer 4, those were transport layer protocols, and they really did the heavy lifting. They carried the data across the network. And in this video, we're going to take a closer look at that. For example, consider the scenario on screen. I've got a client that wants to go out to a web server. And we'll say this is a non-secured web server. We'll talk about secured web servers in a moment. But let's say that this client, let's say it's you. You want to go out to your favorite web server. Well, what's it going to look like if we were to analyze that packet? Well, there would be a source and a destination IP address. And we'll get into IP addresses in a big way later on in this course. But for now, just understand that you've got this logical address that we call an IP address. The destination web server, it's got a logical IP address as well. But as we go into that web server, how does it know that you're trying to reach a web page as opposed to something else, as opposed to maybe connecting via Telnet or perhaps trying to download a file via TFTP? Well, it's going to look at the port number and the protocol you're using. Now, specifically, if you're going to a web server, if it's a non-secure web server, if we're using HTTP as opposed to HTTPS, we're going to be using TCP port 80. That's called a well-known port. Now, you can certainly go in and configure your web servers to use something else, but by default, HTTP, that protocol, uses TCP port 80. So it's using the reliable TCP protocol to carry the web information, and it's using a specific port to say, hey, I want to go to a web service. Now, if this were secure web services, HTTPS, instead of port 80, it would be port 443. And that's one of the things we need to understand for the Network Plus exam. We need to be familiar with many of the popular, some of the well-known port numbers associated with different protocols and what those protocols do at a basic level. And that's what we're really going to focus in on in this video. But back to our story. The client is communicating with the web server. Notice the source IP is the client's IP. The destination IP is the server's IP. And the destination port, because I'm trying to reach a web service on that server, is port 80. Specifically, it's TCP port 80. But take a look at the source port of the client. That's an odd number, 12,048. Where did that come from? Well, as we're setting up this session with this well-known port number, we need to have a source port. We need a port to which the web server can send information back to us. So what we're going to do by default is pick one. We're just kind of going to randomly pick a number that's 1,024 or greater. So in other words, greater than 1,023. For your notes, you might want to write this down. That randomly selected port number that's greater than 1,023, that's called an ephemeral port number. Now, 1,023 or below, those port numbers are referred to as well-known port numbers. And we're going to be taking a look at a bunch of those in this video. So this is the way that we connect and communicate with the web server. As it's sending information back to us, notice things get transposed. The source and the destination IP addresses are flipped. Suddenly, the web server is the source, and the client is the destination. And we're also flipping or transposing the ports. Now, we're coming from the web server, so we're coming from port 80, and we're going to this ephemeral port on the client. So at this point, we understand that web services, non-secure web services, they by default use TCP port 80. But like I said, we want to know a lot more for the exam and for the real world. This shows up a lot in the real world as you're analyzing a packet capture, for example. So what we're going to do is go through a couple of tables where we're going to be considering well-known protocols. We'll discuss briefly what they do, and we'll say what TCP or UDP port they use. And sometimes it might use either one. It could use TCP or UDP. But to start off with, let's consider FTP, the file transfer protocol. This is where we're transferring files from some host. For example, when I'm writing a book for Cisco Press, oftentimes I will use their FTP site. Or we'll talk about secure FTP as well. I use that sometimes. And that lets me send or download these Microsoft Word documents to and from their FTP site. Now, I've got to log in. They give me a username and a password to use, so you have to log in with credentials. So we say that, yes, that adds a layer of security. However, if somebody were to capture these packets, one of the downsides of FTP is it's not secure. It's not encrypted. So somebody might be able to interpret what we're sending back and forth. But for your studies, I'd like you to know that this uses both TCP ports 20 and 21. And if we're connecting into a host or maybe a router or a switch in our network, It's a best practice to use secure shell because, as the name suggests, it's secure. We're going to use some sort of a terminal emulator that supports SSH, and it's going to allow us to have a secure and encrypted connection with the destination host. And it's going to use TCP port 22. Now, remember how we said that FTP by itself did not do encryption? It wasn't really super secure. Well, we solved that with secure FTP. This sends FTP over an SSH connection. And since we're going over a secure shell connection, it's the same port. It's TCP port 22. Another way of doing secure copying is to use SCP, the Secure Copy Protocol. This is going to be similar to SFTP. It's going to give a file transfer service over a secure shell connection. One thing that distinguishes it, though, from SFTP is that when we're looking at the file information, we can see the file's original date and time information. You don't get that with secure FTP. But again, because we're using secure shell as our transport, it's the same port number. So far, the memorization shouldn't be too hard. We've only looked at a few port numbers. So again, it's TCP port 22. Now, remember I said it's a best practice to use secure shell if I'm connecting to a host or a router or a switch? Well, it's a worst practice to use Telnet, but a lot of people still do. Telnet is used to connect to a remote host via some sort of a terminal emulator. Now, personal confession time, I still use Telnet a lot. It's typically in a lab environment when I'm setting up to do a class or to demonstrate something because it's so easy to use. But Telnet sends information in clear text, and yes, I've captured Telnet packets with a packet sniffer, and I can see password information. I can see every single character somebody is typing for their password, so it is not secure. But it is something that's well known and widely used still, and it uses TCP port 23. Now, let's think about email. When you are sending email as opposed to receiving email, it's common to use SMTP, the Simple Mail Transfer Protocol. And the non-secure version of that is going to use TCP port 25. You might see that as you're setting up an account in an email client. Now, if you're going out to, let's say, Amazon.com from your browser, what has to happen is that name, that domain name of Amazon.com needs to be translated into an IP address, because routers, they're going to forward information based on a destination IP address, not on some name. So we've got to have a translator somewhere in the network. We've got to be able to translate Amazon.com to some corresponding IP address. And that's the job of a DNS server. DNS, that stands for Domain Name System, and that's what it does. It takes a name like kwtrain.com, amazon.com, and it converts that into a corresponding IP address, which can be routed by a router or a multi-layer switch, as we'll be talking about later on in this course. And technically, it can use either TCP or UDP to pull that off, and it's going to be using port 53. Now, remember we said that FTP was a way that we could give credentials to log in and download some files or to send some files. Well, there's sort of a lightweight version of FTP. It's called TFTP, Trivial File Transfer Protocol. Typically, we do not have to enter any user credentials here. And like FTP, it's going to send it unsecured, unencrypted. But oftentimes we use TFTP to quickly download a configuration file for a device that boots up on the network. The first example that came to my mind was an IP phone. You've probably seen some of these phones in hotels and businesses. Maybe you have some in your place of work. But these IP phones, they communicate with one another, not using a traditional telephone line, but using an Ethernet cable, using IP for their protocol. Well, oftentimes those IP phones, when they boot up, they need a configuration. They need to know what their phone number is. And it's really common for them to download their configuration via TFTP, and that's going to be done on UDP port 69. Now, when a PC boots up on the network or any sort of other network device boots up, it needs to have an IP address. And a really common way of getting that IP address, because it would be administratively taxing to go around and touch every single device and give every single device an IP address, what we do instead is dynamically or automatically obtain those IP addresses using DHCP. So let's say I turn on my laptop, it connects to the network and says, hey, is there a DHCP server out there? And hopefully there's going to be one that responds, and it says, yes, I'm a DHCP server. And then we say, oh, could you please give me some IP address information? So we're going to get information like an IP address, maybe a subnet mask, a DNS server's IP address, a default gateway's IP address, so we can get out to the rest of the world. That's going to use UDP port 67. Now, earlier we were talking about connecting out to a server on port 80, and we said that was HTTP, Hypertext Transfer Protocol. That's going to allow us to retrieve content or even send content to a web server, and that's a really common one you need to know, TCP port 80. It's not secure though. We'll talk about the security in a little bit. Also, we mentioned SMTP was a way that we could send mail, but how did your email client retrieve mail? One option, it's not really as desirable as another option, but we still see it out there. It's POP3, Post Office Protocol version 3. This retrieves email from an email server, and it uses TCP port 110. And one of the reasons it's not as widely accepted as IMAP, that we'll be talking about in a bit, is it will, by default, download all of your messages and actually remove those email messages from the server and put them on your device. That means if you check your email from your phone and your laptop and your computer, you could have different sets of emails in all those different places. The ones that were active when you downloaded to the phone are not going to be visible on your laptop or your computer. So that's not too great, but it's still out there and it uses TCP port 110. Another protocol that used to be more popular than it is today is NNTP, the Network News Transport Protocol. Back in the day, people used to read news articles on what was called Usenet. There were these Usenet news servers, and you could post and you could read news articles using NNTP, and that used TCP port 119. And it's also critical that our network devices know what time it is. A Network Time Protocol, or NTP, can do that for us. It can allow us to synchronize our internal clock, the internal clock of a router or a switch or a server. We can synchronize that internal clock with some trusted authority out on the network. Maybe it's on the internet. Maybe we have a trusted authority on our network that learned its time from this trusted authority on the internet. But that NTP server, that trusted authority, can give us very accurate time, so we can all agree on what time it is. And that uses UDP port 123. And there's a lighter weight version of the Network Time Protocol. It's called Simple Network Time Protocol, or SNTP. And technically, SNTP is going to put a little less processor burden on your device. The algorithm that it uses to calculate and try to make its time super accurate, it's not as advanced, it's not as involved as the NTP algorithm, and as a result, you can converge quicker. That's a good thing, but on the downside, the time is slightly less accurate than NTP, and it's probably not going to be enough to really matter to us, but technically it's a little less accurate than NTP. Let's look at a few other protocols. And remember, we want to spend some good quality study time memorizing these for the exam. Now, the next one is the one I mentioned a few moments ago, IMAP4, the Internet Message Access Protocol version 4. That is seen a lot in email clients as a way to retrieve emails from a server. And it's preferred over POP3 because with IMAP4, and this depends on how you have things exactly set up on your server, but oftentimes IMAP4 will leave the messages on the server after you read them. That way, your phone, your laptop, your desktop PC, they're all pointing to the same repository of messages. So you're not going to have a scattered bunch of emails here and some other emails here and other emails on this other device, because they're all looking at the server, and you can create a folder structure to organize things on that server, and that uses TCP port 143. Next up is Simple Network Management Protocol, SNMP. This has been around for a long time. It's gone through different versions. Currently, we're at SNMP version 3. But basically what it does, it allows one server to become an SNMP manager. And we can have monitored devices on the network, like routers and switches and other servers. We can have them as SNMP agents. And one thing we can do with SNMP is we can have that SNMP server, often called an NMS, a network management server. We can have that SNMP server go out and query information from those managed devices, those SNMP agents. For example, we might go out and ask, what is the temperature in your chassis right now? Sometimes we might have an air conditioning fail in a server room, and we might have equipment getting really, really warm. I've experienced that a few times. And that's not good. Equipment can fail when it gets too hot. Well, one of the things SNMP can do is periodically go out and say, hey, what's the temperature where you are? And it can send us an alert if we pass some threshold to say it's starting to get warm in this room. And we've got a video on SNMP coming up later in this course where we'll learn more about it, but I need you to understand that it's sort of two different kinds of communication going on here. We've got the server querying information from the managed device, but also the managed device can be proactive and it can alert the server if a certain condition happens. For example, let's say that the temperature did rise above a certain threshold in a router. Well, that could fire off what's called an SNMP trap. And we're going to be able to send a trap to this SNMP server to say, hey, you told me to watch out for the temperature getting too high, and I think it's getting really warm in here. Now notice we've got a couple of different protocol port numbers that we could use, and this could be for either TCP or UDP. We're going to use port 161 when we're requesting information from the managed device. So a managed device is being queried by the server. But if that managed device wants to proactively send trap information to the server, that's going to use port 162. Next up is LDAP, the Lightweight Directory Access Protocol. This is a way that we can have a single repository for usernames and passwords and other user information in our company. This way we don't have to log in separately to get to our email, to get to a printer in the next room, to get to file services, to get to anything that we typically have to log into, because all these services hopefully can point back to the single repository of username information. And that's our LDAP server. And it uses TCP port 389. And we mentioned that there is a secure way of doing web services instead of HTTP. It's HTTPS. This is the secure version of HTTP, and it's going to use encryption as it's sending information back and forth between the client and the server. Got to know this port, TCP port 443. Next up is SMB, Server Message Block. This is something we typically see on Microsoft networks, and this is actually quite old technology. But with SMB, we could use broadcasts to announce the presence of some service that we're sharing. Hey, I'm sharing this folder with people in my work group, and people in my work group could see that I'm making this folder available because they're receiving those broadcasts periodically, and they're going to be able to share that information. But this is not a really efficient way of doing things. This goes back to what Microsoft used to call their LAN manager approach, and it was carried over into Microsoft Windows NT, and now it's still supported in Microsoft Windows Server, but it's really older technology. We prefer to use IP-based communication. But CompTIA tells us we need to know that SMB for this exam uses UDP port 445. Next up is RSH, Remote Shell. This is going to allow us to execute a command on a computer that's remote from us. So it's not our local computer. This is oftentimes used in the Unix or Linux world, and it uses TCP port 514. RSTP, the real-time streaming protocol, is used with media. For example, audio or video, and we can control the playback of media from a media server using RTSP, and it can use either TCP or UDP port 554. Remember, we talked about LDAP as being a single repository for username information? Well, there's a secure way of doing LDAP, and that's LDAP-S, which is LDAP over SSL. This is going to securely send our LDAP messages over an SSL or a secure sockets layer connection. Either UDP or TCP could be used on port 636. Next is H.323. This is an ITUT recommendation that we can use on voice gateways as one example to set up and to tear down multimedia calls if we're setting up a voice call or a video call. There are even some IP phones that use H.323, and we can point to my gateway's IP address and say, to get out to the rest of the world, to get out to the telephone system, the PSTN, the public switch telephone network, I'm going to send this H.323 message over to this IP address, and hopefully it's going to set up the call for me. And that uses TCP port 1720. RDP, the Remote Desktop Protocol, that's going to allow us to remotely control the desktop of another user's computer. This is a Microsoft protocol. This is often used in technical support or people that just want to control their work computer when they're out of the office. This uses TCP port 3389. Now, notice these last couple of protocols, They're not what we consider to be well-known protocols because their port number is greater than 1023. However, they're somewhat standardized. They're almost always going to be using those port numbers. Now, a competitor to H.323, and many people, including myself, would argue that it's better than H.323, is SIP, the Session Initiation Protocol. This can be used to set up and to maintain and to tear down multimedia calls, similar to H.323, but it can be a lot more powerful. There's a lot more information that we can send via SIP as compared to what we can send via H.323. For example, we can send what's called presence information. In a telephone network, I could look at my phone and I could see that I better not call you right now because you're busy. I can see that there's a light next to your speed dial on my phone, so it tells me that you're busy right now, you're on the phone, I should not bother you. Or maybe you're busy because your Microsoft Outlook calendar says you're busy, and that can illuminate that light. And this presence information, that's just one example of what can be sent over a SIP trunk. And port number wise, we can use port 5060 for unencrypted calls, that's commonly used, and port 5061 for encrypted calls, and we can use either TCP or UDP. Now, for your studies, I recommend that you go back and pause the video, take some notes, and I want you to memorize. I know it's a lot of memorization, but this is just one of those videos where you've got to do some memorization. I want you to memorize all the port numbers for these corresponding protocols, and I want you to know at a high level what each protocol does. This will be a great opportunity to use some flashcards. You might get some 3x5 note cards, and on one side write the protocol name, and on the back side write the port number and a brief description, and just test yourself. So your card says, IMAP 4. Well, you should know that's TCP port 143 and that it's used to receive email from an email server. And while this has not been a comprehensive list of all the different protocols out there, this is a comprehensive list of what CompTIA says we need to know related to ports and protocols for the exam.